To search for signs of life beyond Earth, astronomers must scan billions of stars across distances so vast they are difficult to conceptualize. This represents the universe's background noise. Radio telescopes are bombarded by a chaotic flood of overlapping signals from stars and galaxies. Finding an intentional signal here is like hearing a whisper in a hurricane. Scientists look for one distinct spike cutting through the natural static. Because the cosmos is so loud and our observation windows are so small, isolating a genuine, unexplained anomaly is one of the most difficult challenges in modern astronomy. On August 15, 1977, at Ohio State University, the data suggested that a whisper had finally been heard. Astronomer Jerry Ehman was reviewing data from the Big Ear radio telescope, a massive array designed to catch faint radio emissions as the Earth's rotation swept it across the sky. During a routine scan, the telescope detected a signal that was significantly stronger than the background radiation of space. It lasted for exactly 72 seconds, the precise amount of time it took for the telescope's fixed beam to pass over that specific point in the sky. When Ehman saw the printout, he was so struck by the sequence of alphanumeric characters representing the signal's intensity that he circled the data and wrote one word: wow. In that moment, this sequence of numbers and letters appeared to be exactly what astronomers had been searching for, a signal that lacked any obvious earthly or natural explanation. To determine if this was a genuine anomaly, scientists had to look at the specific data parameters that separated this 72-second burst from normal cosmic noise. Natural cosmic phenomena typically broadcast over a wide range of frequencies, but this signal was narrowband, meaning its energy was concentrated into a tiny, specific slice of the radio spectrum. This is exactly how we would expect a beacon to look if it were designed to be seen across interstellar distances. Beyond its frequency, the signal's intensity was remarkable. It rose and fell in a near-perfect bell curve, matching the telescope's sensitivity pattern as it moved past the source. The telescope tracked the source to the constellation Sagittarius, a dense star field where we expect to find many potential star systems. The signal's strength, its narrowband frequency, and its location in a dense star field were all characteristics that scientists had theoretically predicted for an intentional extraterrestrial broadcast. However, the scientific method requires a process of elimination. Before concluding that this was an alien signal, researchers had to test every possible natural explanation. They first ruled out standard stellar emissions. Stars and galaxies produce radio waves, but not in such a concentrated narrowband format, and not with this level of sudden intensity. One hypothesis suggested that rare hydrogen gas emissions might have caused the burst, but even these natural events tend to be broader and less focused than what was recorded in 1977. Scientists also looked at terrestrial causes, such as Earth-based radio interference reflecting off space debris, satellites, or passing comets. Each of these theories faced a major hurdle. None of these events have ever been observed to produce a signal with these exact characteristics in that location again. After decades of systematic testing, every known natural explanation has been scrutinized. While some remain possible, none have been confirmed as the definitive source. In the years following the detection, astronomers pointed telescopes back at that exact coordinate in Sagittarius, hoping for a repeat performance. They found nothing. Since August 1977, that region of space has remained completely silent. This creates a replication paradox. In science, a discovery must be repeatable to be considered proven. This chart shows the single, isolated 1977 spike followed by nearly 50 years of an empty baseline. Without a second detection, the signal cannot move from a curiosity to a proven event. It remains a singular data point that exists outside our current understanding. To this day, the true origin of the WOW signal remains one of the most significant unsolved questions in astronomy. This pullback shows the difficulty of the search. Each of these millions of stars is a potential source, and a 72-second signal can be easily missed if a telescope isn't pointed at the exact right spot at the exact right second. Our ability to find an answer is limited by our observation windows. We are only listening to small portions of the sky for very short periods of time. The WOW signal exists as a record of a brief window that opened in 1977 and hasn't reopened since. It serves as a reminder that the universe is capable of producing events that we can record but cannot yet explain.